Hi students, are you running short of time? It's your examination next week. Are you desperate? Do you need to do some quick revision? If you do, this video is for you. In this video, I'll be doing quadratic equations and inequalities and completing the square. So do stay till the end. Right, let's start off by revising the nature of roots of quadratic equations. So what are they? So for quadratic equations in the form ax squared plus bx plus c equals to 0, where a, b, and c are real numbers and a not equals to 0, we can find the two roots of the equation using, yes, the quadratic formula. And in this quadratic formula, there's something that's very important that's inside the radical form, and that is your b squared minus 4ac. And this b squared minus 4ac is called the discriminant of the quadratic equations, usually denoted by the capital letter D. And what does this discriminant tells us about the roots of the equation? Yes, the two roots can be classified as two real and distinct, meaning, let's give an example, it could be x equals to 3 or x equals to negative 4. So if you have two real and distinct roots, that means the values of your discriminant has to be more than 0. It has to be more than 0, then possible to get two real and distinct, two different values for x. So two different values for x means you have two real and distinct roots. How about two real and equal roots? To get two real and equal roots, how would that happen? Okay, wait. Let me try to draw a diagram for you so that you can visualize what it means by two real and distinct roots. So if I have a more than 0, that means the coefficients of x squared is positive. I have a U-shaped curve. So to get two real and distinct root means this is what I have, x1, x2. Alright, so now let's look at two real and equal roots. So to get two real and equal roots means it only intersects the x-axis at one point. And that happens only when your b squared minus 4ac is equal to 0. And sometimes when you have b squared minus 4ac equals to 0, it also happens when if you have a curve and the tangent line. So the tangent line will intersect the curve at only one point. And that will give you two real and equal roots. And that is when you can use b squared minus 4ac equals to 0. Alright, so the third kind of roots will be no real roots. And that happens when your b squared minus 4ac is a negative value. Okay, because if you were to use a calculator to square root a negative value, you wouldn't get an answer. Okay, so it means no real roots. So that happens when b squared minus 4ac, the value for b squared minus 4ac, it's a negative number. And of course, and the last type of the roots is called real roots. It comprises of two real and equal roots and two real and distinct roots. That means it combines this one and this together. And that is when the value of b squared minus 4ac is more than or equal to 0. So these are the four different types of roots, okay, that you have to keep in mind when we're managing this chapter. Right, so now we have understood the nature of the roots of a quadratic equations. Let's extend the knowledge further to what happened if you have a curve intersecting with a line or a line intersecting with a curve. What are the possible number of intersection points that you can get? Supposing if you have a line where I call it y equals to 2x plus 1 and a curve which is y equals to x squared plus 6x plus k, let's see what are the possible situation you can get when this line meets this curve. Right, so there are three possible cases. First of all, we can have this line intersecting the curve at two intersecting points, or just intersect at one point, or there's no intersection at all. Right, so to solve this kind of questions, how do we go about doing it? Yes, we need to generate an equation in X. Okay, meaning because we need to let x squared plus 6x plus k equals to 2x plus 1. Simplify it. How do you simplify it? That means you bring your 2x plus 1 to the left hand side. And you simplified it to get x squared plus 4x, because 6x minus 2x gives you 4x. And k minus 1, you just bracket it, because basically k minus 1 is the constant term. There's no x there, so it's a constant term. Alright, so we need to generate an equation in terms of x. And what's next? Let's look at the next slide. Alright, so from these equations, we can write down the values of a, which is the coefficients of x squared. In this case here is 1. B, which is the coefficients of x, which is 4. And as what I've mentioned earlier on, k minus 1 basically is the constant term, so represented by the letter C. So we can substitute this value into b squared minus 4ac. And the value of your b squared minus 4ac will determine the nature of the roots for the equations. Right. So if the value you get is more than 0 here, it means that it refers to the first case where your curve intersects the line at two real and distinct points. If the value you get is equal to 0, then we conclude that it intersects at one point. And this line is also called the tangent line. And if the values you get is negative value for b squared minus 4ac, then we're saying that the curve does not intersect with the line. So this is how you can go about solving problem involving a line and a curve. Right, so what I've done in this slide is to summarize for you the different kind of questions that you may encounter based on the same kind of roots. What do I mean by saying that? Supposing if you have b squared minus 4ac less than 0, what sort of roots do you have? Yes, there's no real roots, right? So you'll be surprised how many different ways the questions can ask you, know. The same concept, no real roots here, but it can be, the questions can be phrased in such way. For what values or range of values of k does this curve have no x-intercept? Okay, so when they say no x-intercept means if you look at this curve here that I'm given, the coefficients of x squared is -3, so it is an n-shaped curve. So when they have no x-intercept means the curve is entirely below the x-axis. So it means there's no real roots. Okay, there's no x value, no x-intercept, so no real roots. Okay, so this is when you used the value of b squared minus 4ac less than 0. Let's look at some other equivalents. So it can also, yes, like what I've just mentioned only, that for what values or range of values of k does the curve lies completely below the x-axis. So it's equivalent to the first one that we asked, have no x-intercept. Let's look at the third one, have no real roots. Okay. The questions can also be such that find the values or range of values of k where the curve is always negative. So always negative means this case here, which means it's entirely completely below the x-axis. Okay, it is an n-shaped curve because the coefficients of x squared is negative. So how about other equivalents? Sometimes they may give you ax squared plus bx plus c is less than 0 for all real values of x, where a is less than 0 is an n-shaped curve like what we mentioned. So less than 0 means it's below the x-axis, means it lies completely below the x-axis. Yes, it can also be the line doesn't intersect with the curve, like what we have meant in the earlier slides. We have discussed the line and the curve. It does not intersect at all. So that is when we have no real roots. And it can also be ax squared plus bx plus c more than 0, that is completely above the x-axis. So that happens only your coefficients of a must be positive, must be a U-shaped curve. It has to be a U-shaped curve, then it's completely above the x-axis. So can you see, for the same concept, we're all talking about b squared minus 4ac less than 0, but there are so many different ways of asking you based on the same concept. Okay, let's look at the next slide. Right, so the next one is, how about if you have two real and repeated roots? What sort of questions do you think you can ask to solve? Yes, when you touch the x-axis. For what values or range of values of k does the curve touch the x-axis? So when you see this word touch the x-axis, means this is an n-shaped curve, coefficients of x squared is negative. It means that touch it. When you touch something, means you touch at one point only. Okay, touch x-axis means touch at one point. And 1 point means you have two real and repeated roots. It means the value of b squared minus 4 is equal to 0. How about another way of asking it? Yes, when this particular curve has two real roots, two real and equal or repeated, and sometimes they use coincident. So these three words, okay, that they are equivalent to each other. It can be equal, repeated, or coincident. It means the same thing. Have one x-intercept. Okay, x1 intercept is equivalent to this here. It touched the x-axis at only 1 point, so one x-intercept. And of course, the last one is when the line is a tangent line. Okay, for what value of m if the line is a tangent line to the curve? Because the tangent, okay, this is a U-shaped curve. The tangent line will only intersect the curve at 1 point. So can you see there's so many ways of asking, but just on the same concept. Right, so let's look at what happens if you have two real and distinct roots. How do you think the questions will be phrased? Yes, for what range of values of k does the curve cut? If you see words like cuts, the x-axis intersects the x-axis, meets the x-axis, okay, at two distinct points. It means like that. And that is when the values of b squared minus 4ac must be more than 0. Cuts, intersects, meets. Okay, but if it's touch only, then it's b squared minus 4ac equal to 0. Okay, it can be like very straightforward. Two real and distinct roots straight away tell you two x-intercepts. Or it meets. Yes, you see these words that we use here? Intersects, meets. You see this word intersect, meets means the value of b squared minus 4ac is more than 0. Alright, so let's look at the last case, which is real roots, where the values of b squared minus 4ac is more than or equal than 0. So how do you think the questions can be phrased? Yes, it can intersect or meet the x-axis. Have real roots, straight away, very straightforward kind of asking you. More than or equal than one x-intercept. It can be one intercept, that is when b squared minus 4ac equal to 0, or it can be more than one. So you must combine both cases. Real roots is when you combine two real and distinct with two real and equal, or when the line meets or intersects the curve. So it's quite similar to two real and distinct roots. It's combinations of two real and distinct roots and two real and equal roots. Alright, so this is a quick revision. So I do try to speak a little bit faster. Alright, so if you can't really catch what I'm saying, you may have to watch it again. Right, so part D, we're going to recap on how to solve quadratic inequalities. Solving quadratic inequalities is entirely different from solving quadratic equation. Okay, they're not the same. Okay, supposing you ask to solve this quadratic inequalities, so what do? Step number 1, we bring, yes, everything to the left hand side. so that the right hand side is 0, and we factorize it. You factorize this equation here, sorry, not equation, factorize this quadratic functions, okay, into two linear factors. And then this is where it's different from solving equation. When you solve equation, you just simply let x equals to -3 or x equals to -half, right? Very easy, right? But solving inequality is entirely different business. So what do we do at step 3? Yes, you have to draw the quadratic curve. Okay, step 3, we have to draw the quadratic curve. So how do you know it's a U shape? You look at the coefficients of x squared. Okay, it's 2. 2, it's more than 0, positive, so it's a U shape. Okay, so this is my x-axis. This x-axis is when y is equals to 0. So this is like like the equator. Okay, above equator is heaven, below equator it's okay. Don't talk nonsense. Never mind. So that is my x-axis. Y equals to 0. Anything above the line y equals to 0, it's y more than 0. So this part here is y more than 0, and then anything below the y equals to 0 is y less than 0. Okay. So basically y equals to 0 is it's like a divider, okay, anything, so that's what I've indicated for you here. Anything above it is positive, anything below it is negative. Okay, right. And yeah, and how do I get x equals to -3? That is when you solve the equation, when you let it equals to 0. So you x plus 3 is equals to 0, right? So x is equals to -3, so that explains this value here. And then 2x plus 1 equals to 0, so x is equals to -half. That explains that value there. Okay, so I'm going to erase this because it's so untidy. I cannot stand untidiness. Okay, erase, huh? Okay, but we need to leave the x-axis y equals to 0 on. Alright, so the next thing is that we need to identify the region that we're interested in. So how do you know which region you're interested in? So go back to the original inequality. You want it to be more than 0. More than 0 means you want it to be the positive region here, this one here, and this one here. Right. So that means the answer that you want is this part of the curve you're interested, right? So corresponding to this part of the curve, the x value, when you solve it, you're finding the x value. So the x value will come from here, from the x-axis. X value must come from the x-axis. So any value here, can you see that it's more than -3? Sorry, less than -3. Let myself back. Okay, any value here, you see that it's less than -3. So that explains our first inequality. Okay, then the second region that I'm interested in is this part here. Can you see? So the corresponding x value have to come from the x-axis. So any value that is more than -half. So we have two sets of inequality here. You cannot combine them. Okay, let me repeat. You cannot combine them. So it's x less than -3, or the or must be there, x more than -half. Okay, you cannot combine them. We're talking about two separate branches. Okay, so you cannot combine them. All right. What happens if you're not given the coefficients of x squared to be positive? What happens if you're given negative? If you're given this? So do you think that the inequality, the solution sets, do you think will be the same way as what we have done? Right, it will be different because if the coefficient of x squared is negative, then we're talking about n-shaped curve, right? So therefore, in order not having to memorize so many things, I would always, okay, encourage my student, if you're given the coefficient x squared to be negative, just multiply everything by positive, and flip the inequality sign. This is very important, okay? This part here, you still have to remember this part here. So multiply every number with negative, flip the inequality sign, so that you always need to deal with the U-shaped curve. So you just need to memorize one kind of shape, and that's it. Okay, you don't have to memorize, oh, for N shape, what should I do? Or for U shape, what do I do? Okay, but you have to remember when you multiply an inequality with a negative 9, you have to flip the inequality sign. So this is important. Right, so now let's come to the favorite part, that is applying what we have learned. Okay, so this is O-level questions from the year 2021, paper 2, question 5. Right, so you're given the equations of the curve. It's 2x squared minus 6x plus 3. Part A, find the set of values of x for which the curve lies above the line y equals 11, and represent this set on a number line. So there are two things we need to do. That is to find the sets of values of x and also represent the answer on the number line. Okay, so what does it mean by having a curve lying above the line y equals to 11? So basically, this is what it means. I have a curve here. How do I know this value here is 3? Yes, this value is your y-intercept value, and that I get it by substituting my x to be 0. Just in case some of you wonder why. For for y-intercept, just substitute x equals to 0, okay? And I have a line y equals to 11. Of course, the line y equals to 11 have to be above the value y equals to 3, right? Yes, so the part of the curve that I'm interested in is the one highlighted in yellow. So I'm supposed to find the range of values of x that correspond to that yellow colored part. Okay, so how do I go about doing it? So basically, I need to have this. Basically, I need to have this y value bigger than this y value. So if I call this y value y1 and this y2, basically I need to have y1 bigger than y2. I need to have y1 above your y2, right? Because I need it to be lying above y2, right? The curve must lie above y2. So what we are saying is I need my 2x squared minus 6x plus 3 to be bigger than 11. Okay, so I bring everything to the left hand side, and what you see, it's a quadratic inequalities like what we have got just now in the earlier slides, and we can actually divide every term by 2 to simplify it, to get x squared minus 3x minus 4 more than 0. 0 divided by 2 is 0. Then we factorize it. Yeah, so this is similar to what we have done earlier on. Okay, solving quadratic inequality. So the next thing is that we draw your quadratic curve. Okay, it's a U-shaped curve because the coefficients of x squared is 1. So the two intersecting point, the two x-intercept, not intersecting point, the two x-intercepts are -1. You let this guy equal to 0, so the x-intercept is -1. Let this guy equal to 0, the other x-intercept is 4. Alright, so above your x-axis is positive, below is negative. Okay, so which region are we interested in? Yes, we're interested in the positive region. Okay, the one highlighted for you in yellow. So the corresponding values will be the two arrows going to the left and right will be a corresponding x value, which is x less than -1 or x more than 4. Okay, and that is not the end, because we're supposed to represent this answer, this answer on the number line. Okay, so please use the ruler to draw a number line. Okay, all right. So there are two points here, -1 and 4. So x less than -1. Okay, it's an empty circle because it does not include -1. So it goes to the left. Please use a ruler to draw also. And the other one, it's at x equals to 4, and then it goes to the right. So this is how we can represent it using a number line. Right, so let's look at part B. So part B, we are told that we have a line y equals to 2x plus k. It is a tangent to the curve. Right, so a tangent to the curve. So what does it mean? Yes, it means the line intersects the curve at only one point. And what does it mean? Yes, it means the value of your discriminants must be equal to 0. It means we have two real and repeated roots. So the values of b squared minus 4ac equals to 0. So you need to have all these concepts inside your head, so that when you see things like that, you must be able to link them. All right. So let's start off by having a curve and a tangent line. All right. So what do we need to do? Yes, we have to find this point here. So we need to generate the equations in terms of x. equals to 2x plus k. You bring everything to the left hand side. Simplify it. Okay, negative 6x minus 2x will give you negative 8x. Basically, your 3 minus k is the constant term. Okay, constant term is the one without x squared or without x. Alright, so we have already agreed that tangent means the value of b squared minus 4ac is equal to 0. Right, so let's write down the values for a, b, and c to substitute into your b squared minus 4ac equal to 0. Okay, and you end up getting this. Simplify further. And you get k equals to negative 5. So that is quite easy for part B. So how about for part C? We're asked to find the coordinates of P. Alright, so after finding the values of k, what do you do with it? Yes. Okay, we substitute k equals to negative 5 into this equation. Okay, because this equations is the equations that we get by equating the curve equals to the line, the tangent line, and that will help us to find the intersecting point. Okay, so that's simplified it. Divide by 2 throughout to get x squared minus 4x plus 4. Factorize it. Oh my god, all the animations are wrong. Never mind. We factorize it. Okay, and then you have x minus 2 times x minus 2 equals to 0. So you can stack it up into a perfect square. And then the opposite of square is square root, right? So square root 0 will give you 0. So x equals to 2. Then you substitute x equals to 2 into your curve to get y equals to negative 1. So therefore, this particular point is 2 comma negative 1, which makes sense. You can, because there's only one intersecting point, so you should only get one x value. So if you do not get one x value, you get more than that, then something is wrong with the solution. Right, so let's look at question 3. Question 3 actually is easier than the first two questions. Basically, you just asked to solve the quadratic inequality. Right, so let's simplify the left hand side and the right hand side. So that will give you 2x squared minus x on the left. On the right will be 5 minus 10x. Bring everything to the left hand side. Simplify it. And what's the next thing we do? Yes, factorize it. Right, and what's the next thing we do? Yes, draw the quadratic curve. It's a U-shaped curve because the coefficients of x squared is positive. So draw your U-shaped curve. Okay, identify the x-intercept. Right, if we were to recall, x-intercept is when I let this guy equals to 0, so I have x equals to negative 5. Let the other guy equals to 0, x equals to half. Okay, identify the region. This is our x-axis, which is y equals to 0. So above it will be positive, and below it will be negative. So which region are we interested in? Yes, the one that highlighted in yellow. I want it to be positive. So the region I'm interested in will be the one highlighted in yellow. And to where do I get my x value? Yes, I get it from my x-axis here, which is anything that is less than negative 5, or here, which is anything more than half. You cannot combine the inequality. Okay, I have been repeating it and repeating it. Okay, there's two different sets of inequalities, so you can't combine them. Alright, we're supposed to represent it on the number line. So please use a ruler to draw your number line. I'll try to draw it as straight as possible. So the two x-intercepts are negative 5 and half. So x more than equal. So it's a solid circle because it includes half. It includes negative 5. So it's a solid circle. Okay, so this is how we do it. Right, so this question is similar to what we've done earlier. This is O-level questions from the year 2019. All right, find the set of values of constant k such that the curve lies entirely above the line y equals to x. So what we are saying is that if I'm going to let this guy be y1 and this guy be y2, what we are saying is that we want y1 to be above y2. All right, so we need to form a quadratic inequalities greater than x. All right, so what's the next thing we do? Yes, we need to simplify it, expand this one, and bring everything to the left hand side. Okay, and here of course we cannot factorize it. Yes, because we have an unknown values here, k. So this one really tests you on your concepts of what we have been discussing so far. All right, if you were to remember the different kind of questions that can be asked based on the different kind of roots. So do you remember for something like this, which category does it fall under? Yes, this is a U-shaped curve, and for it to be always more than 0 means it lies completely above the x-axis. So what kind of roots do you think this curve will have? Yes, this curve will have no real roots. So if this curve has no real roots, then what do we use? Yes, we use the value of b squared minus 4ac less than 0. So that's subbed in the values of b, which is 2k. B is the coefficients of x, which is 2k here. Divide by 4 on both sides. Okay, so the danger comes, that's a danger here. Why do I say it's a danger? Because many folks will go on and do this. Okay, which is ridiculous, which is wrong. Okay, you can't do that. Remember, we are solving quadratic inequality. We're not solving a equation. So you can't do that. Then what do we do? Yes, you factorize it. Factorize k squared minus 1 is something like your a squared minus b squared. You can factorize it to be k plus 1 and k minus 1. Okay? And then draw your quadratic curve. The two k-intercepts. The two k-intercepts is negative 1 and 1. Identify the positive and negative region. We're interested in less than 0. So we're interested in the blue region there. So the corresponding x value will be anything that is between negative 1 and 1. Okay? Your x value is anything here, right? Anything here, anything here, which is between negative 1 and 1. So here you will have only one set of solution set, inequality set. Yes, k more than negative 1 and less than 1. Okay, so this is how you solve these questions. Right, so let's look at the last questions, question number 5. And this question is involving completing the square. Right, so I'm just going to do a very quick, this is part I. This is I. Okay, let's look at part I. Right, so we need to express it in the form. This is called the completed square form. So let's rearrange it first. Let's put your negative 2x squared first, plus x plus 3. So basically, I need to complete the square for this guy, but I cannot do anything until I make the coefficients of x squared 1. Okay, very, very important. I need to factorize my negative 2 out. Okay, and this will become negative half x. All right, we don't worry about the positive 3. Okay, we leave it alone first. Okay, right. So how do I get negative half here? It's quite easy. You just take the coefficients of x, which is 1, isn't it? Just take 1 divided by negative 2 lor. So 1 divided by negative 2, isn't it negative half? That's how I get this answer here. Okay, right, can Okay, so I need to perform completing the square for this guy. Okay, so there are two ways of doing it. Okay, one way it's I need to add something. Remember, what is it that I need to add? The one that I need to add is the coefficients of x. Divide by 2, square it, and then take away. Because I cannot change the question, right? So add something is you have to take it away. It's like give you $1. It's like I don't want to give you the money. I don't want to give you the money at all. So I just pretend give you $1 and then take it back. So it's like not giving you anything. Okay, I don't know whether that is a good example. Okay, never mind. Right. So this is what it means. Then this one will be your a squared plus 2ab plus b squared. This is where I can make it into bracket x minus, okay, where do I get a minus? You just look, concentrate, you just, okay, where do I get a minus? You see, you have to do this correctly, then that's how you get a minus. Here, whatever inside here is where you put it here. So negative half divided by 2, it's negative 1/4 squared. Then minus again your negative half divided by 2 is negative 1/4. You need to square it, so they give you 1/16. Okay, so this is one way of doing it. Another way it's I call it the shortcut way. What is the shortcut way? Let me show it to you what it means by the shortcut way. And that is, you know that it has to be something squared, right? You know that it has to be something squared, right? You know that it must be it must minus something here. And of course my plus 3 is outside lah. Leave it unmolested. Okay, so what is inside here is just basically x, and then you take this guy here, negative half divided by 2, so that gives you negative 1/4. And what I need to minus off is 1/4 squared. Okay, so what you have here is the same, all right? But it's really up to you whether if you're more comfortable with this method, then go ahead and do it. Okay, whichever method you are comfortable in. All right, so I'm going to erase everything and do again. All right, so we're going to factorize your 2 out. So I will have x squared, and the coefficients of x is 1, right? So basically this value here is just positive 1 divided by negative 2. Take 1 divided by negative 2, so that gives you negative half, and then plus 3. Okay, so far so good, huh? Right, so we need to complete the square for these two terms. So we know that it must be something squared, then minus something squared. So what is inside there is just basically x. Oh, I missed out my x here. So sorry. I missed out my x. So what I need to have here is basically just take negative half divide by 2. Negative half divided by 2 gives you negative 1/4. Negative half divided by 2 gives you negative 1/4. So what I need to have here is negative 1/4. Okay? And then minus away who? Minus away 1/4 squared. Or you can put negative half there also. Just to make sure that consistent since I put negative 1/4, so I just put negative 1/4 there also be consistent. Okay, so far so good. So this will be negative like that. And this one, they use a calculator, you work out negative 1/4 times negative 1/4 will give you 1/16. Okay, we're not done yet. You still have to multiply your negative 2 into your big square bracket. So that gives you negative 2 bracket x minus 1/4 squared. We use a calculator if you need to. That will give you positive 1/8 plus 3. Then we simplify further. That will give you 3 and 1/8. Okay, so that's how you solve it, how you express it in the form, completed square form. Right, so we are not done with part I yet. Alright, we still have to find the values of A, H, K, because these are the values that, these are the constants that need to be found. So we're going to compare it with what you're given. So from there we can see that A is equals to negative 2, H is negative 1/4, and K is 3 1/8. Right, so that is part I. So for part 2, we are asked to find the values of C such that this equation has real and distinct roots. Okay, so we need to understand how the curve looks like. So from what we have gathered here, since the coefficients of x squared is negative, so we know it is a n-shaped curve. So the maximum point will be 1/4. How do you get 1/4? That is, you let this equals to 0. Right, so x will be 1/4. And if that is 0, 0 plus 3, 1/8. So your maximum y value will be 3 1/8. So in other words, your curve will look like this. The y-intercept will be at 3, because you substitute x to be 0 here. Y-intercept is 3. Then the maximum point is 1/4, 3 1/8. So this is how your curve looks like. Okay, right. So what we are saying is that this is my y. So what we are saying is that we have a line. The line is y equals to c. It's a horizontal line. Okay, we want to draw a horizontal line such that when you intersect the curve, it will give you two real and distinct roots. So supposing I draw my line y equals to, my horizontal line is in this direction, you'll see that it will intersect the curve at 2 points here, right? That will give us 2 intersection point, which is satisfy my 2 real and distinct roots, right? 2 intersection points means there are 2 roots, right? 2 real and distinct roots. My y equals to c, my horizontal line can be like this. It still give me 2 intersection point. It still give me 2 intersection point. It still give me 2 intersection point. If it touches at the maximum point, then what happens? You'll see that I will only have 1 intersection point, right? So this is not what I want. I want it to be such that I must always have 2 intersection point. So therefore, this line here, this value of c has to be strictly less than 3 1/8. Okay, it has to be here, 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 here. Basically, any value that's less than 3 1/8, that will give me 2 intersection point. Okay, so the answer for part 2 will be C must be less than 3 1/8. Right, so I hope this quick revision will help you to prepare you for your end of year exam. So good luck to you.